Solve the problem. Find the lengths of the three sides of the right triangle. Here we have a right triangle with legs of x and x plus 4, a hypotenuse of x plus 8. The Pythagorean theorem is used to solve for unknown lengths of right triangles, and it says leg squared plus leg squared is hypotenuse squared. Or you might think of that as a squared plus b squared is equal to c squared. Well, let's let a be that variable x, b x plus 4, and c x plus 8. So we have our equation in terms of x. Let's solve it. I'm going to go ahead and solve it by beginning to square each of these binomials. So as our next step, let's write x squared plus x plus 4 times x plus 4 is x squared, plus our inner and outer products are both 4x. 2 of those gives 8x, plus 4 times 4, or 16, is equal to x plus 8 quantity squared is our first term squared, x squared, plus 2 times our inner and outer products. 2 times 8x is 16x, plus 8 squared, or 64. Now let's put this quadratic equation in standard form. I'm going to move terms over to the left-hand side. On the left we have 2x squared minus x squared gives a 1x squared. We have an 8x on the left. If we subtract 16x from it, that 8 minus 16 gives a negative 8, then times x. Let's also subtract 64 from both sides. 16 minus 64 is a negative 48. We've got our quadratic equation in standard form, and this is going to factor, so let's use the factoring method. That factors as two binomials with leading terms of x. Factors of negative 48, they're going to make this work, are a minus 12 and a plus 4. Quickly checking our inner and outer products, negative 12x plus 4x gives that middle term negative 8x. So now for our zero factor property, x minus 12 is equal to 0, or x plus 4 is equal to 0. That yields x equal 12, or x is equal to negative 4. Now, remember that we're solving for sides of a triangle. And if x represents one of those legs, then it cannot take on a negative value. So we're going to, right off the bat, reject negative 4 as a possible solution, a length of a leg of a triangle. But over here, x is equal to positive 12. That makes sense. And if x is 12, then the other leg, identified as x plus 4, is 12 plus 4, or 16. And our hypotenuse, identified as x plus 8, is 12 plus 8, or 20. Let's quickly check to make sure that these lengths satisfy the Pythagorean theorem. In other words, is leg squared plus leg squared equal to hypotenuse squared? Is 12 squared plus 16 squared indeed equal to 20 squared? That's 144 plus 256. Is that equal to 400? Yes, it sure is. That's a true statement. So we've got the lengths of the sides of our triangle. They are 12, 16, and 20.